Let us have a look at this problem. This problem is basically of capacitors, RC circuit basically, and although this is a relatively good question, but this is easy, right? And let us first of all see, because it is directly based on the formula. Let's see with the capacitance of a capacitor discharging through a resistor R, right? It is discharging. So for discharging basically, we know the formula. We know the formula that Q equal to Q naught e raised to power minus t by tau, right? Now tau where is RC, in an RC circuit we know this. Now it is saying suppose T1 is the time taken for the energy stored in the capacitor to reduce to half of its initial value, right? Now energy is given by what? Half Q square by C, right? So initial value, initial was UI, initial was what? Half Q naught square by C, right? And now finally U final is half of its initial value. That means half Q square by C. Now this is half of the initial value, half of half Q naught square by C, right? Now we will put the value of Q. Now Q is given by this equation. So that means I can write that e raised to power minus 2 t by tau will be equal to half, right? This I can mark. This is the first equation. Now for the second part it is saying, and T2 is the time, this is basically T1 time, right? So T2 is the time taken for the charge to reduce 1/4 of its initial value. That means Q naught by 4 should be equal to Q naught into e raised to power minus T2 by tau. This is the second equation basically. So this will give me that e raised to power minus T2 by tau will be equal to 1 by 4, right? This is the second equation. Now I have to calculate the value of T1 by T2, right? The ratio of T1 by T2. So what will I do? I will take ln both sides, in equation 1 also, in equation 2 also. This is not equation 2, this is basically equation 2. So if we use ln in equation 1, basically if I use ln on both sides, it will give me minus 2 t1 by tau will be equal to ln 1 by 2, or I can write it as t1 will be equal to tau by 2 ln 2, right? Because negative will come over here and ln half is minus ln 2, so minus minus will cancel out. Now this, let us mark as third equation. And to the second equation, to this equation, what will happen? If I take ln on both sides, in equation 2 what will happen? It will be minus t2 by tau will be equal to ln 1 by 4, or I can write it as t2 will be equal to tau ln 4, right? Now if I divide third and fourth, I will get t1 by t2 will be equal to 1 upon 2 ln 2 divided by of ln 4, and we know that we can write ln 4 as twice of ln 2. I can write this as, this means these will cancel out, so t1 by t2 will be equal to 1 by 4. That means option C is correct. So although this was relatively good question with compared to whatever is asked in AIEEE, but this could have been easily done because it was just dependent upon the basic formulas, that's it, right?